Hello guys, Mr. Middleton here. Today we will talk about multiplication properties of exponents. By the end of this lesson, I hope that you're able to multiply exponents and that you'd be able to do or work with scientific notation. Okay, so let's start and just look at a few exponents right now. Okay, so I have 8 to the 6th power written out. I have it written out twice. What I want to point out is grouping, how we can group these things together to show our multiplication properties of exponents. Okay, so both here we have 8 to the 6th, and you know that 8 to the 6th just means 8 times itself 6 times. Okay. And what I want you to notice is that I've group these a little bit differently. Here I have 8 to the 4th, as I group these together, and 8 squared. So 8 to the 6th equals 8 to the 4th times 8 squared. And 8 to the 6th also equals 8 to the 3rd times 8 to the 3rd. Okay, if you have a calculator and you want to try that out to see if that works, you should find that it works in both situations. Okay. And the reason that it works is because our multiplication properties of exponents. Okay, and here's how it goes. If our exponents have the same base, here I'm just giving a and a to the m to stand it in for some numbers, and a to the n, notice that they're both a, the base is the same. If they have the same base, then when we multiply them, what we're really doing, or I guess a shortcut of how we can see it's happening, is we're adding the exponents. Okay, so here we had 8 to the 4th times 8 squared. That gave us 8 to the 6th. 4 plus 2, 6. Here we had 8 to the 3rd times 8 to the 3rd. Again, same base. We say 3 plus 3, which is 6 to the 6th. Okay, so let's look at some examples and see how it goes. So in these examples, we have 3 to the 5th and 3 to the 4th. 3 to the 5th times 3 to the 4th power. So we can kind of rewrite that following this rule as 3 to the 5th plus 4, which will give us 3 to the 9th power. Okay, if they have the same base, we can add their exponents to get their product. Here, just outline, we have h squared and h to the 9th. Same base, both of the bases are h, so our new base will be h. Okay, squared and h to the 9th, 2 plus 9. Oops, maybe I should write it that way. 2 plus 9. And that will give us h to the 11th. Alright. Here's some more examples. You can feel free to pause it and try them on your own and then fast forward to see if you get the same thing I'm getting, or you can follow along with me. So again, same base, 11, 4 plus 3. This should give us 11 to the 7th power. Here we have 2, same base 3 times, so I have 2 to the 5th, and I'm adding 2, and here's a negative exponent, and so I'm going to subtract 1. Okay, so I have 5 plus 2, which is 7, minus 1, which is 6. So this should be 2 to the 6th. Okay, and then here I have 3 squared plus negative 2 or minus 2, which gives me 3 to the 0 power. And that should remind us of what we've done today, actually. 3 to the 0 power, anything to the 0 power is just 1. Okay, so to simplify our expression, we don't want to have any negative exponents. We don't want to have any 0 exponents either. So that answer will be 1. Hopefully you feel pretty good about that. Let's see some more examples, and we just have a bunch of them, so I'll lay them out. If you feel comfortable with it so far, you can try them out on your own, or you can follow along with me. Alright, so fourth example, we have x times x squared times x to the fourth. Now this is a problem that's commonly missed, and here's why. There's no exponent written here. Okay? But anytime there's not an exponent written, that means it's to the first power. Okay? Because again, 1 is a number that we just don't write a whole lot because we just understand it should be there unless it's not written. There's no 1 in front of x to the fourth, but we know that's 1x to the fourth. Okay, same thing with our exponents. So when we're multiplying this, we have x, because they're all the same base, x 1 plus 2 plus 4. So it gives us x to the 7th power. Should have given myself a little bit more space, but that's okay. Here we have 2 into the 5th times 3 into the negative 2nd. Okay. We already know how to multiply numbers. 2 times 3 stays 2 times 3. It's not addition. Okay, that's still multiplication. And then we'll just regroup. We'll group these to help make it helpful for ourselves. Okay. We have n to the 5th times n to the negative 2nd. Since they're the same base, I'm going to subtract them. So this answer should be 6, that's 2 times 3, into the 3rd power. Okay, adding a little bit more to it now, we're looking at some different bases, some negative exponents. Okay, kind of putting all of our stuff together. We have c to the 4th times d to the negative 3rd times c squared. So I see that I can group my c's. I have c to the 4th, c squared, so I'm adding those two. Okay. And then I have d to the negative 3rd. I'm going to separate this into more steps than I would usually do it, but just so we can see what's happening. So 4 plus 2 is 6. I have c to the 6th. And d to the negative 3rd. Now remember, I can't combine these because they aren't the same base. That's why I didn't subtract 3 from 4 plus 2. And this isn't my final answer. Can't be, because I have a negative exponent. So in order to make this my final answer, I will want to move this. Remember, these two are tied together. I want to move this to the denominator. Okay. So our c to the 6th stays in my numerator. C to the 6th over d to the positive 3 now that I moved it to the denominator. G, going through a good list of examples. So notice the rule is not that difficult. We're adding those together, but using all of our established rules with it will give us a little bit more challenge than it would seem just from the simple rule. So G, I have a bunch of numbers, 5 times 2 times 3. Those still the same things that we were doing, so I'm going to group those together because I know I can multiply those. It's not a new concept. 5 times 2 times 3. Okay, you don't have to write it out like this, but I find it helpful to do so. Especially as we're introducing this topic. Okay, I'm going to group my x's together because I see I have x here and x here. Remembering that if there's no exponent written, that number is 1. Okay, it's not 0. And then 8, because that 8 here. So I group those together. And then I have y to the 4th. Again, maybe I wouldn't separate this out like this later on in this chapter, but kind of the introductory lesson is helpful to see how we're getting to our final answer a little bit more. So 5 times 2 is 10, 10 times 3 is 30, x to the 9th, y to the 4th. And there's no real rule, but as a rule for myself, I like to make sure I keep my variables in alphabetical order, because that's just a way to organize myself, that I've gone through everything that I need to go through. Okay. And now this final example, we're going to use this same information in order to simplify scientific notation expressions. And we've done problems like this, except we didn't have the extra scientific notation. But now we should be able to deal with it a little bit easier. Okay, this is not a foiling problem. I don't know if we've talked about that yet. It's not a distribution problem. But what we're going to do is we're going to just group these things a little bit. Just multiplying 7 times 4. Okay, group those together. 10 squared times 10 to the 5th. Group those together. Okay. And again, these have the same base, so I could actually just say 10, 2 plus 5, right? 7 times 4 is 28. So 28 times 10 to the 2 plus 5. I have 28 times 10 to the 7th. If I wanted to write that in scientific notation, which I do just because it's already there, kind of, then I will want to move this decimal. Instead of being here at 28, I want to move it 1 over to the left. Okay, so from here I'll have 2.8. Make sure this is on the screen. 2.8 times 10. Now from here it told me to move to the right 7 spaces. So if I move my decimal to the left 1, that means I'll have to move to the right 8 spaces. Alright, and so that is our multiplication properties of exponents. You should be able to use those properties, use them in scientific notation, understand that if the base is the same, then we can find the product by adding the exponents. Alright, see ya mañana.